Okay, so here is a problem or example when we're going to launch it with an upward angle, but we're going to launch it from ground to ground, okay? I'm going to give you two solutions. One is going to focus around this maximum height, right? And then the other one is going to focus around the total time. But again, remember, we're going to start with our steps. So we're going to do VOX, VOY. I apologize, I didn't read the question. So an object is launched from the ground with 50 meters per second at 37 degrees and later returns to the ground. Find its time to reach the maximum height, the total time of flight, and then the horizontal displacement, again, which is the range. So when you have these angle problems, right, this is where you're going to have to use your sine and cosine functions that we spoke about. So it's going to go VO cosine theta for the x, VO sine theta for the y. Okay? So we're going to do 50 cosine 37, 50 sine 37, right? Because that was our initial velocity. It was 50 meters per second at 37 degrees. Now, this is a 3, 4, 5 triangle, in case you didn't realize, but all you have to do now is plug it into your calculator, making sure you are in degrees, okay? And you'll find that the x component is 40 meters per second, and the y component is 30 meters per second, okay? And so now we're going to write our functions, just like we did before when we did the launch horizontally. And so our functions don't change. X equals 40t, right? Because now we're not going to use the 50, we're going to use our component, which is 40. And now we're going to write our y. Okay, so our initial y position is 0. I'm going to put this y out in front, even though I know it's going to end at 0. But I'm going to put it out there because we're writing just the general function. It's going to be 30t minus 4.9t squared. Okay, so there is step 2, right? Writing our functions. Now step 3 is solve the problem, right? So there's a couple ways that we can solve this problem, right? One is we can do this stuff here at the max height and then go to C and D, right? Where and you got to remember from class, time to rise equals the time to fall. So the max height is the mathematical vertex, right? And so if I focus on the max height first, okay, what I'm really going to do is I'm going to find the vertex of that parabola, because remember, this is a parabola because of the squared. And all I'm going to do is plug in negative b over 2a. And you do have to recall that my little saying that physics writes math backwards. Okay, c is 0, b is 30, and a is negative 4.9. Right? What we mean by writes math backwards is physics starts with a constant and builds its way up, where math starts with the highest order and builds its way down. So we're going to do negative 30 divided by 2 times negative 4.9, and so that'll give us the answer to part A, which is the time to get to the max height, which will be 30 divided by 9.8, which is 3.06. Sorry, I got too close to the scroll bar here. Okay, so that's 3.06 seconds. Okay, now what is the maximum height? Now I do is plug in that 3.06. I may run into the apologize for that. Okay, let's make that term squared. So y equals 30 times 3.06 minus 4.9 times 3.06 squared. And so we get a maximum height of 45.9 meters. Okay, so there's the answer to B. Here's the answer to A. Okay. Now C, when you do the problem this way, the total time is just simply 2 times the max height time. So for us, it's going to be 2 times 3.06, which is 6.12 seconds. All right. And now the range, we can go back over now to our other function, right, our x. And since we're looking for the total range, we're going to do 40 times 6.12. Then it's going to be a range of 244.8 meters. Okay. All right. Kind of now, this problem has like one of those alternate endings, right? Just like some movies do, where you can do alternate endings. So now I can focus on my total time and go up to my maximum height. So I'm going to do that solution in blue so you can see how this works. Now, if I were just to treat this as a parabolic function or quadratic function, I can factor out a t, right? Because t is common to both terms. And I know it's going to hit the ground, so it's going to be 0, right? So it's going to, my final y position will be 0. Okay, and now because this is multiplication, I know one or two things has to be 0. Either t equals 0 or 30.49 equal, or 30 minus 4.9 t equals 0. And so all I do here is solve this for t, and I end up with 30 divided by 4.9, and guess what I get? 6.12 seconds, right? Okay, which then I can go over here, plug that into my function, right, my position function, and guess what I'm going to get? 244.8. Okay, now the difference also lies where the time to get to the max height is 1/2 of the total time. That 6.12 is my total time. All right, so all I have to do is 1/2 of 6.12, and guess what I get? 3.06 seconds, which is what I found over here, right, for my maximum height time. And then I take that 3.06 seconds, plug it back into my 30t minus 4.9t squared, and guess what I get? This right here, the 45.9. Okay, so what you can see is there are alternate ways to, there are multiple ways to solve this problem. Okay, now this only holds true for ground to ground, right? That's the thing to remember, is that this is my path, right? If I'm doing a parabolic function, my y versus t, okay, this is my starting point, this is my ending point, and then up here, right, is my max height. This does not hold true if I land above my starting point, or I land below, or I leave, you know, if I land above my starting point, okay? This only holds true as long as your vertical displacement, your delta y, is 0, okay? But that is it, okay? If there is a vertical displacement, you can, like, all bets are off. You cannot, you have to go through the full steps. And more than likely, you're going to have to use quadratic equation to find the time to get to the flight time, or the total time. Now, from here on out, we're going to look at other launch at an angle problem, right? We're going to do ground to height, height to ground, and then negative launch angle.